Now I'm going to talk about how do we map the relations between objects in the domain model into relations in the database. So there are several patterns about this, from the foreign key mapping, association table mapping, dependent mapping, embedded value, and serializable log. So the main problem about this is that in some situations you inverse the relation between the entities. So sometimes when you suppose that you have a one-to-many relationship where an object has a list of other objects, but in the database this is implemented and each one of the objects in the list contains external key for the owner of the list. And this impacts on the way, so but the basic problem about this is that in memory, after changing the list, you need to decide what are going to change in the database. But in memory, you don't have the values about, you only have the list. So it's not easy to distinguish in this list which objects are new, which objects, because in the database you don't have this reference. So before doing, you have several solutions to this. Okay, so before doing the SQL that changes in the database, what you can do is just you read the current state in the database and you compare them in memory, and then you decide which ones you need to read, which ones you need to delete or create, whatever, or update. Okay, so this is one problem. There's some solutions that try to optimize this, that we read about these solutions. For instance, you can basically use some type of brute force, but actually is faster, which is you just delete the complete list in the database and write the new list. This works fine if there are no other objects that refer to the elements in this list, so that if these objects actually are contained in the list. And this is strongly related with dependent mapping. So if they are in the context of a dependent mapping, we are talking about the foreign key mapping, but in the context of dependent mapping, you can apply these easier. Okay. Then we'll learn other techniques to do this, and always the concern is how do you optimize so we do the changes in memory. How do you decide which SQL queries or which SQL commands you are going to execute in the database? Okay. You will have the association table mapping. So the foreign key mapping actually applies to solve one-to-one relationships and one-to-many relationships. For the association table mapping, you deal with many-to-many relationships. And for instance, in this case, you have so in this case, basically, you can look here. You have a table that is a relational table that basically contains the pointers to the two participants in the relation. And so if you want, given an employee, you want to get a set of skills, what you need to do, you need to do a first query to get all the employees that have the employee ID. And then for each one of them, we do need to do a query to get the skills. So you do a lot of queries in order to get this list from memory. And so in this pattern, they discuss this and how you can probably optimize it. Look, that optimization here is relevant from 2 points of view. The first one is this code is generated. So if you are going to generate it, you try to write it really optimized when you generate the code, right? Actually, you are generating in the GPA. And the other thing is that this occurs quite frequently, right? Because we are changing things in memory right into the database, so that it's a set of actions that occur quite frequently in your application. So probably is worth optimizing them. Okay, and then you have these patterns, which is embedded value, serialize, and serializer log, that actually is a particular examples of dependent mapping, which means that you have a dependent mapping, means that you have an object that actually contains other objects, one or more objects. And actually what you need to do now is that probably you can manage the persistence of these objects that are contained. Okay, you can manage them in the context of the container. Okay, and again, this works fine if there are no reference from outside to it. And this can come to the situation, for instance, of embedded value, where actually you contain a single object, and instead of having a different table, you put this object inside the same table. So you have a larger table that contains the container and the containee. Okay, so and then you have something more complex that is serialized lob. Is the same idea that actually you have some attributes in our table that contains, but in this case probably you have a set of complex objects that are related, and if you start mapping each object of these network of objects into tables, we'll get some awkward structure, and probably you will need to do a lot of joins to get information. So the best idea to do is that you just serialize it and you store it as a large object in an attribute. Okay. Then you have two problems to this, and well, you have two solutions, but the main problem now is how can you. So once you have do it, you cannot go with SQL and read what is inside that. So you only can read it when you bring it back to memory. Of course, there is one solution. You can do something there, not directly to SQL, because you can either serialize to a binary format or to a text format. If you serialize to a text format, you actually can read it. Okay, and in particular, if you serialize to XML, you can use XPath, but depends a little bit. So you can use XPath to read what is inside. So inside SQL, but it depends if your database management system allows you to embed SQL commands inside, XPath commands inside SQL. So read them and see the different forces that are here involved and how they provide the implementation of relations between objects. Okay, good.